So I got to thinking, and while I'm doing my latest Profi 2.2 install vid, this is the switch that's going into the Kanan Jarrus hilt, along with this switch. Got me thinking that there's a lot of questions about switches, and everybody's like, well, which switch do I need to buy to wire my lightsaber? Well, I'm going to put a bunch of switches out here and show y'all all the different kind of switches that there are that can be used. And you have these micro tactile switches. There's a gazillion different kind of switches that you can use and buy. I have an assortment of tactile switches here, and these have 4 legs on them, so I'm going to get one out to explain tactile switches. But the first things first, a lot of y'all buy these Saber Forge and Ultra sabers that have what's called a latching switch. Now, a latching switch works differently than a momentary switch in that it enables power. So what I'm going to do is I'm going to hook the negative leg up to this LED from my test battery, and then I'm going to hook the positive up to my latching switch, and then my positive continues through the latching switch to the LED. And I'm going to press my latching switch, and I get illumination. What's happening is the latching switch is actually completing the positive circuit to the LED, turning on the LED. This is a typical stunt saber setup using a latching switch. The difference is when we're using soundboards, like this is an old Teensy saber, these soundboards do not use latching switches. What's happening is these soundboards use a momentary switch like these, and a momentary switch clicks and then unclicks, clicks and unclicks, so it's only on when you touch it. And what's happening with these momentary switches is they send a signal to the computer that tells the computer to do something with the lights. They're not completing a circuit. A momentary switch sends a signal to a computer. So if you're using a modern soundboard, CFX, Teensy Saber, Profi, Nano Biscotti, they utilize momentary switches. Now there are some exceptions to this where you can use a latching to momentary converter, but I'm talking about in general. In general, modern computer soundboards use momentary switch signals, and then the computer, the processor on the board, interprets that signal to do whatever the programming on the board tells it to do when it receives that switch signal. So in computer soundboard lightsabers, we use momentary switches to relay a signal to the computer, hey, a switch has been depressed, or a switch is being held, and then the computer interprets what to do with that signal. So I'm going to show you, I'm going to hook up a momentary switch onto this same LED and make the same circuit here in a second. Okay, now I've hooked up this momentary switch up to my LED. The positive lead from my battery is connected to this gray wire, which goes into my momentary switch. The yellow wire coming out of my momentary switch feeds the positive on this LED, and the negative battery terminal is hooked direct to the LED. When I depress this momentary switch, the LED comes on, but when I let it go, the LED turns off. So when you're watching this, I want you to think about this light as a signal. If the computer program perceives that it was briefly touched, it's sending that same signal that's allowing this to be illuminated to the soundboard. If it's pressed and held, it sends a signal to the soundboard, hey, I'm being pressed and held. So your soundboard can actually differentiate between a long press and a short press. Even on Nano Biscotti. How you change fonts on Nano Biscotti is you press and hold the switch through 2 beeps. So it's going to cycle through the font on a long press. But it knows if you just do a short press, then it initiates the lightsaber. And the lightsaber illuminates on Nano Biscotti, which is a single switch saber. So these momentary switches are used to send computer signals to the soundboards instead of actually completing a circuit. So that's why these latching switches, which click on or click off, they're a little bit beefier because they're designed to carry the full amp load of the LED through the switch, because this is like a light switch. We're turning on the light or turning off the light. Whereas these momentaries are not an on-off switch. They only complete a circuit momentarily while they're being pressed. That's the difference between a momentary switch and a latching switch. So now that we know that most Saber soundboards are using momentary switches to send the soundboards a signal. What switch do you need in your lightsaber? Well, there is a gazillion different kinds of switches. In my Profi install into my Kanan Jarrus saber, I'm using this 16 millimeter momentary switch. This is not illuminated, but they make illuminated ones too. I'll show you an example of this illuminated, and it's going to go into this switch housing, and the nut attaches on the back. And there's only two poles, one for ground and one for your switch post on your soundboard. This is an illuminated 16 millimeter anti-vandal switch, and it has 4 poles. And I'm going to wire one up and show you how it works here in a second. And usually on these illuminated switches, there will be a little tad of paint that tells you what color it is, and this one's purple. But on the illuminated switches, there's a positive symbol here and a negative symbol here. So on the positive and negative legs, those are what power the LED in the illuminated part of the switch, are the positive and negative. The other switch posts are for ground and your actual switch post on your soundboard. So this one will go to ground and this one goes to your switch post. You can actually connect the ground and the negative together and just run one wire to negative, and then you're good there. Then you just have a switch wire and a positive coming off these. So you can do a 3-wire setup on an illuminated switch. But I'm going to wire one up and show you how it works here in just a second. So on these illuminated switches, if you're going to use negative to the ground pole on the actual part of the switch, then you want to put your resistor on the positive line. I'm not going to do a class on Ohm's law, but you should calculate your resistor for the light in the LED based on Ohm's law. Here I'm using the appropriate resistor, and it's on my positive line. So remember, I told you one pole is positive, one pole is negative. I got my test battery hooked up to negative, and I'm going to hook up my positive pole to the resistor, and you can see that the illuminated LED illuminates. It's that simple. But that illumination circuit on the LED is totally separate from the actual switch mechanism. So now that we know how to power these illuminated LEDs, I'm going to show you how the actual switch mechanism works. So I'm going to bring in my handy dandy voltmeter, and I'm going to put it on audible test pulse, just like that. And I'm going to hook one pole to one of the switch outputs and the other pole to the other switch output, and we're going to depress the button, and you hear the tone. That's the signal that it's sending to the soundboard, the computer soundboard. So again, the 4 poles on these illuminated switches, the positive and negative are for, turn that off, the positive and negative are to power the LED in the switch, and the other 2 poles are for the switch. Does it matter which one is ground and which one is switch? No, either works. They're just, one goes to ground, one goes to your switch pad on your soundboard, and it just gives the soundboard that signal that I told you these momentary switches are sending. So not every lightsaber gets a 16 millimeter anti-vandal or a 16 millimeter momentary. There are also 12 millimeter. This is an illuminated 12 millimeter. It's got 4 poles on it. This one is actually a blue one, and this is a 12 millimeter switch. This is a 16 millimeter switch. The difference is the diameter, but this one is an illuminated 12 millimeter anti-vandal switch. You have tactile switches like this, which I buy an assortment of these tactile switches to have on hand, because you never know what kind of switch you're going to need in your lightsaber. I use these tactiles quite a bit, but they're again a momentary switch. They have 4 legs on them, 1, 2, 3, 4. The way these switches work is, see this line running down through the switch? This leg is the same as this leg. This leg is the same as this leg. So when you're hooking up these switches, you either have to hook up this leg and this leg, you know, ground and switch wire, or ground and switch wire, or ground and switch wire. But if you hooked up this leg as ground and this leg as switch wire, then you would get nothing on your signal, because there's continuity between these 2 legs. So when you depress the switch, you get no continuity in the switch. So you either have to wire this one and this one, this one and this one, this one and this one, but you can't wire this one and this one. And I'm going to put up a diagram that shows you how to wire these tactile switches. You only need to wire 2 legs, not 4. They do have 4, and that's basically designed for when you're putting these into a breadboard, but you only need to wire 2 of them. Only 2 of them need to be wired to your wires of the 4 legs, but got to pay attention on how you wire those. Here is the actual tactile switch that I'm going to be installing into my Profi Saber. Now I've made a brass switch hat for this one, and how I made this switch hat is a cool secret. Jedi Sith did a tutorial on how to make these switch hats off of brass standoffs, and I'll post a link to Jedi Seth's video at the bottom of this video in the expanded comments section. Now, we also have other small tactile switches like this, and you can see how small that is. These switches are commonly used in Graflex clamp switch holders. This would go inside of a Graflex clamp, and then the clamp, you would have a clamp card that covers the switches, and when you depress the clamp bar, it depresses either this switch on this side or this switch on this side. This is how we get clamp switch activation, and it's utilizing these small tactile switches. The cool thing about these smaller tactile switches is they only have 2 legs, so you know it's very obvious which leg you solder ground, or you don't have the 4 legs to choose from. You have ground and you have your switch wire, and that's very simple on these very small switches that fit in these Graflex clamp switch holders. You have even more micro switches. This is a small switch, and you can see how small these are. And these are, again, they have 2 posts on them. They're very small. When I solder these switches, I have to do it under a scope because I can't see it if I don't. They're extremely small. These switches do also have some applications. Then I have these switches, which these are also very small tactile switches with very small leads. The leads that you solder to are here and here on these switches, and these are very small. And these are often used in chassis that use plungers to depress the switch that's in a removable chassis. And I buy these in bulk in a strip just like this. So, which switch goes in your lightsaber? That's a long story. We don't use latching switches in computer soundboard sabers unless you use a latching to momentary converter, which is very advanced, so we're not going to talk about that. So that's all about switches. If you have comments about switches, please write them in the comments and I'll try to answer you. But the bottom line is, everyone asks, which switch do I need for my lightsaber? Well, I don't know. Which lightsaber are you installing, and what type of switch design and application do you want in your lightsaber?